For the second half of Chapter 7 audio lecture, we're really going to focus on vaccination. So we talked about T and B cells. Those cells give specific immunity, and this is the ability to combat disease and cancer. However, this immunity can be brought on by natural occurrences, or it can be brought on through artificial means such as medical intervention. So there are two types of immunity, active and passive. Immunization is an example of using active immunity as well as getting an infection. So when you get an immunization, you are injected with, let's say, part of a bacteria's cell wall. And if you remember from the picture of the antibody binding to that bacteria cell, you don't need the entire bacteria to initiate an immune response. You just need that foreign molecule, those little square boxes, the triangle, that rounded molecule on the surface of the bacteria cell. So you can be injected with any part of that cell wall, and your immune system is going to recognize that as foreign. And so then your immune system sees that after it's been injected into you and begins the process of mounting an immune response. The first exposure is going to be called the primary exposure. And this is seen here in this figure down here. There we go. Primary response follows time 0, that is your primary exposure. And this blue line is looking at the antibody levels in your blood that are specific to that material in that vaccine. So the primary exposure, very short, right? Pretty short in nature, in time. But then you have a second exposure to the vaccine. A lot of times you have to get boosters. So here, when do you get the DTP? Right, at 2 months, 4 months, 6 months, 15 to 18 months, and then 4 to 6 years. So you're getting exposed specifically to these 3 organisms 5 times in your life, specifically. All right, and so each time you have an exposure, you increase this immune response. So it's very powerful. This type of immunity is usually long-lasting, meaning that it can actually last you your entire life. So typically you don't have additional vaccinations after middle school or sometimes high school when you get those boosters. And that's because it's lifelong. Right, but it also depends on the memory B cells and T cells that are there and that can reproduce upon subsequent exposure. Then passive immunity. This is passive. You're not actually doing anything. All right. Passive immunity is given to you by the mom or directly giving you antibodies. All right. So if you remember, the particular antibody that crosses the placenta is IgG. And so here this is passive for this infant. The infant's immune system isn't doing anything, but rather it's the mom's immune system making these antibodies that move through the placenta into the circulating blood of the infant. All right, also with another example is breastfeeding. All right, IgA to small amounts and then IgA, those are again different types of antibodies, are secreted into breast milk. So even if a mom is only able to breastfeed the infant for 2 or 3 months, that is fantastic because it's after the infant is born, it actually takes several months for their immune system to mature. So any additional antibodies that that infant can get from the mom is going to help and be extremely beneficial to that infant. All right. Next, had an issue with the mouse there. All right, antibodies can also be injected by a physician. So one good example is snake bite, and you are given an antitoxin, right? Because that snake injected venom into you, and you need something that's going to counteract that toxin very quickly, right? What that physician is going to give you in the emergency room or wherever are going to be antibodies specific to that snake's serum, and they're going to bind to that toxin, that serum, and drawing a blank here on the word, make it so it's not going to work. Hopefully you can, you're picking up that word I'm trying to neutralize. It's going to neutralize the toxin. Alright, and since you didn't make your own antibodies in terms of this passive immunity, it's short-lived. So the purpose of having antibodies pass through the placenta, the purpose of breastfeeding, is again to give that infant as many antibodies as possible while their immune system matures, because the antibodies given by mom in utero are actually only going to be detected for several months, maybe at very, very low levels at age 6 months, but by then the infant's immune system is doing its own job. Right, so how can the immune system react that may be harmful to the body? This can be allergies, hypersensitivities to pollen, to food, animal hair. And these responses are generally immediate. And the immediate allergic response is due to IgE. And this is one of the isotypes of antibodies. And they are specifically involved with allergies. And they are part of, not the Y-shaped or the top end of that antibody, where it's going to bind the antigen, but on the base of the antibody. The base of that antibody actually binds to cells that are called mast cells, and then those mast cells release histamine. And histamine is a simple chemical. It plays a role in the inflammatory response, but it also plays a role in you having itchy eyes and runny nose, and those type of, and eventually problems breathing, all right, those type of allergies. It's this response, this chemical sequence that is causing that. All right. You can also have more severe allergies, such as anaphylactic shock. If the allergen reaches the blood, there is what's called delayed allergic responses that are actually initiated by T cells. And this is one example of this is poison ivy. So if you come into contact with poison ivy, you may not know it the first time, because the first time you don't get a reaction. The first time your immune system sees it, the T cells are activated and nothing happens. The second time, though, then your T cells are going to respond, and they cause the blistering, the rash, the itchiness, the pain that can occur with poison ivy. It can also be tissue rejection in terms of someone receiving a organ transplant, blood transfusion. There can be rejection of that because your immune system can recognize that as foreign if it's not typed properly. All right, then it's the lymphocytes that recognize the organs as foreign. And so in almost all cases, a person needs to take immunosuppressant drugs forever, right, to dampen down that immune response, that the ability of the immune system to react to try to keep that organ functioning and the immune system still thinking it's their own. Right, some more disorders of the immune system. There's autoimmune diseases, and that's when the immune system attacks the host, right, attacks the cell, and some examples of this are multiple sclerosis, lupus, rheumatoid arthritis, myasthenia gravis, and then there's immunodeficiency diseases. Right, the immune system is compromised and thus unable to defend the body against disease, and a pretty prominent example of this is AIDS, or acquired immunodeficiency syndrome. So just some review. List 2 chemical and 2 physical barriers, 2 invaders. And I'll let you do this on your own, but can you think back to the first part of the lecture notes about what chemical barriers there might be, what physical barriers? Right? What's the difference between passive and active? Right? Active, your body is doing something. Passive, it's not. What's the sequence of events for the inflammatory response? What are the 4 outcomes of the immune response? Another thing to look at. What is the sequence of events in B-cell mediated immunity? All right, summary. There's bacteria that are alive, viruses that are not alive, that are the main invaders to our body, and then there's also cancer. The organs of the lymphatic system are the spleen, thymus, lymph nodes, the bone marrow. Our lines of defense, physical, chemical barriers, inflammatory response, and the cell-mediated, so first, second, third line of defense. And you have 2 types of immunity, passive and active. And last but not least, you can have disorders within the immune system, specifically allergies and immune disorders.